Great to see so many people here this afternoon. I hope you all are enjoying the conference. My name is Patrik, and I'm really excited about being here at GDC. This is actually the fourth consecutive year that Tobii has been running our multi-million-dollar program, which is aimed towards game developers implementing eye tracking into their games. And the big news for this year is that we're extending this program into VR. And that's really what we're going to talk about. We're going to focus on the use cases, usage scenarios, and we're going to talk about the value that eye tracking actually gives to VR. And we really see that eye tracking is the next natural step for VR. So hopefully you have a better understanding of what we actually mean by that after this session. But before we dive into that, I really want to spend some time and reflect on what's been going on over the last 12 months from an eye tracking perspective. So a year ago, when we were here at GDC and we were running our program, we were meeting with developers where we were talking about eye tracking and implementing eye tracking into games. The situation looked, from an eye tracking perspective, dramatically different from what it looks like today. So to us, I would say 2016 was very much, we reached a tipping point. And the reason why I'm saying that there's several things. The first reason is that a year ago when we were here, there were really no hardware out there. So, when I say hardware, I mean consumer-grade hardware. The big brands, there were no products out there with eye tracking built in. So during 2016, today, there are more than 10 different products out there actually supporting eye tracking with eye tracking built in. And I'm talking about laptops, I'm talking about monitors, and I even talk about smartphone. So companies like MSI, Acer, and Dell with their gaming brand Alienware all have released products with eye tracking embedded in them. So that's from being no consumer-grade products on the market to actually having more than 10 products out there is a huge step. So that's the first big thing that happened during 2016, comparing the situation today from then. The second thing is that there are way more games than it was last year. And perhaps most important, there's some really big titles also. So I would say they're like, depending on how you define a AAA title, but there are almost 10 AAA titles, or at least very big games out right now that is supporting eye tracking. And that wasn't really true to the same extent a year ago. But then there are other things than just hardware and games. You actually see that some of the really major players out there are making investments in people that understand eye tracking and investment in eye tracking technology. And if you take one step back and you look at the big macro trends, you know that ID identification built into the hardware is something that everybody is looking at. Artificial intelligence is also happening. If you look at the smartphones today, and you know that there's a lot of AI in all these hardwares. And what that is really all about is, a requirement is today that the hardware knows who you are, and the hardware wants to know your intention. So you have these really big trends happening. You have the big companies investing in eye tracking and eye tracking technology. You have hardware, consumer-grade hardware out there. You have games. So I would say the landscape is very different today than it was just a year ago. So with that said, I'd like to hand over to Joakim, and we'll focus on eye tracking and why it's the natural next step for VR?
2 years ago, we decided to really make a push into VR and adding VR to eye tracking to VR. And, we had already quite a long experience from doing wearable eye tracking from our professional research business. But what we really saw was that VR is a big consumer thing. And, just as a PC, just as actually we're doing in mobile phones as well, that, volumes of eye trackers will be shipped. So we've been working on this, for the past 2 years, and we started on actually building our platform using the GDC Vive headset, HMD, because of the fact that it is the gold standard for VR, and it also has the kind of form factor that most of the other upcoming HMDs also will actually copy or be very similar. And the optics and the geometry of the actual HMD is very important. So we are in our third version of our prototype from a hardware and electronics perspective, and we're starting to get in a really, really good shape when it comes to the eye tracking quality of the actual HMD. And that means that now we're taking the next logical step and start driving content into this area, because of the fact that when there will be consumer available HMDs with eye tracking, when they will be available, at that point there needs to be content as well. So we're working really hard on that. So the purpose today is actually to show you some of the things that you can actually use this for. But so touching on some of the main use cases that we look at is basically for VR that are essential. I'm just listing 4 areas of use cases here. The first one is foveated rendering. And this is predominantly an enabler for the HMD manufacturers. Because of the fact that it is possible to render graphics with high resolution basically where you look, where you glance. That means that you have the opportunity to render with lower quality in the rest of the field of view. And that actually enables, a potential save on GPU. And I think that's also specifically important for the untethered HMDs that we are seeing quite a lot of development around right now. They have less horsepower, so all the capacity really needs to be oriented in an efficient way. And eye tracking is actually an enabler for that. Also, we know the true pupil position of the user in 3D space. That also means that right now, all the graphics in VR are rendered as if the person was looking straight ahead, but they don't always look straight ahead. When you move your eyes, the position of your pupil actually changes. That means that there is an offset of where you render the pixel and where it's actually hitting the eye or the retina. And that means that, but if you know exactly where the eye is positioned in 3D space, that means that you can actually correct the graphics in order to actually send the photons where they should be. Also, when we are all very different as people, so some people have a very wide IPD, interpupillar distance, some people have a very narrow interpupillar distance, and it's actually quite not super easy to put on an HMD correctly. But because of the fact that with eye tracking you know where the eyes are, you can help the user actually position the HMD so that the eyes are in the optical center of the lenses, which is quite, it's an easy use case, but it's very important. But then, of course, then it's all about what kind of experiences can you, as a developer, provide using eye tracking. And that's what we're going to show some demos, avoiding the perils of live demonstrations of VR. We've recorded some videos for you, and I'm going to go through them, some of the areas what we have been exploring. We have a team doing user interface exploration. We have a team doing foveated rendering exploration. We have a gaming team with 15 people. So we're actively exploring what you can do with this technology as a developer. We want to make VR truly immersive. When you have eye tracking, you are, as a developer, you know the intent of the user. Because it's like this, when I want to engage with something and interact with something, the first thing I do as a human being is actually look at that thing. And so that means that where my gaze is actually where my intent is. Some people usually say, well, I can do two things in the same time. Well, we all know that they lie. Well, you can do two things, but you can't be attentive to two things at the same time. Just go out in traffic and see how many people actually hit someone else when they thought they could use their phone whilst driving. So by looking at something, you show intent and attention to something. So intent is really, really important. What we look at things that we are about to interact with. That means that the developer that knows where the person or the user is looking already know quite a lot of what the person is about to do. And that means that you can make things much more real because you're aware of what the user is about to do. So what we want to do, and because virtual reality, you hear virtual reality. Right now, virtual reality is quite unreal. It doesn't really behave the way where we expect it to do. You point using a laser beam from your forehead like this. You use hand controllers that are sometimes fantastic, sometimes wonky. And the only way to actually show intent is to stand in a virtual environment, is to aim your head towards it. That means that you're moving your head in very much more than you usually do when in real life. That means that you become exhausted. And then we render imperfectly. That means that people get nauseated. So, in my opinion, VR is quite not real right now. And the goal is to make it more real, more immersive, and actually more fun. So let's talk about some things that you can do. Avatar interaction. So imagine that you have a multiplayer game of some kind, where you have an avatar representing you. Right now, what you can see is usually that you have an avatar that has a 1,000-mile stare, just looking really, really not alive. But if you actually do eye tracking and enable eye tracking of the user, you get this kind of experience instead. An avatar where the eyes are moving, where you can actually see where the person is looking. And you can see if the person is looking away from you, even though the head is facing you. So this is a key user experience, and it's a key use case to making actually VR much more fun. So another thing that's usually done using a hand controller is teleportation. But as you can see in this video, teleportation can also, because of the fact that the application knows where you are looking, you can make teleportation dead easy. I'm looking at an area which is this yellow, the cylinders become yellow when I actually look at them, and then I just press the trigger to teleport down into that area. So as a complement for the regular way we do teleporting in VR, just looking and interacting or choosing is also one very simple way of doing teleportation. Because of the fact that the game or the application knows where you're looking, you can start designing experiences that behave more like you want them to, or actually make you succeed as a user, or actually have more fun as well. So I'm going to show you a demo where you throw stones. So in VR, when you throw a stone, the success of throwing the stone is basically only dependent on how good you are at moving the hand controller. So, but in real life, when I want to throw something at something, I actually look at it. So I have a magic stone in this demo, actually, which is gaze aware. So just by looking at it, I can pick it up. I look at it and I press the button, I pick it up. And also it knows which bottle I'm looking at. So hitting a bottle becomes dead easy with this stone, of course. So because you know what the intent is of the user, what I'm looking at, then you know what he's gonna or she is gonna throw at. It's as simple as that. So this kind of natural interaction is very much a good thing to do in VR. So making things gaze aware, either if it's gaze assisted throwing, gaze assisted aiming, gaze assisted shooting, the key thing is that you know what the person is intending to hit. And then you can decide whether how much you want to help the user do it. But the thing is, it's much, much more real. Rapid selection, the eye is really, really good at a few things. So of course looking, but also the eye is really good at rapidly moving towards a place where it's fixating. Basically, so I look around and the eyes focus very, very fast on one point. That means that selecting things using your eyes, or actually identifying things using your eyes, is very, very good using your eyes, as opposed to your head. Doing like this in order to select a certain object here, it's hard. We're not built to do it. It's not actually generally humanly usual that you do that. But what you do is that, but with your eyes, it's perfectly, perfectly natural. So I'm just going to show you a video of that as well. So in this game, we actually have drones flying around, sending missiles towards you. And the user actually finds the missile immediately using his or her eyes, and then guides the missiles back to any drone that you actually look at. And the thing here is what you can do in this with this functionality is to make things really, really fast-paced. Because if you want to choose in between many different objects really, really quickly, then if you want to do that with your head, then you will go like this, and then you will be exhausted after 5 minutes. But here you can do this using your eyes and have really, really fast-paced interactions, because you can pick things as fast as your eyes move, which is really, really fast. And the eye tracking signal that comes out of this system, or in the stage we're at right now, and what usually is interesting, is at about 120 hertz per second, which means that there is, it's quite sufficient to drive all of these use cases. And then let's talk about what we call intelligent interfaces here. So in this demo, we have different kind of objects that react to gaze in different ways. So for instance, we have the TV. When you look at it and press the button, it just actually switches the channel. We have a roof slider that reacts to, you look at it and then you go like this. But then we have the two droids. Having droids or having things that react to your gaze is essential. And one of them is giving me money, which is great, because we also have noodled around with different kind of menu choices and interacting with menus using your gaze. So we have the Alexa here, and I bought some kind of animal. And in this video, you also see that there is a sort of a cloud around the objects. That's just a way of representing your gaze where you're actually looking. And also we're experimenting with different kind of telekinesis things. Basically, you look at an object and then you manipulate them using your hand controllers. And exploring the physics of that and the feeling of that, it's amazing much fun. And also what you see here in the end of the video is a way of, after the game session, looking at a representation of where did the user actually look during the session. So you see the pink rays. They are actually one way of representing what the pattern of usage was during the game session. So if you're in a situation where you want to explore, is this game working? Are they paying attention to the right things? Are they seeing that thing? You can use eye tracking in actually analyzing the behavior of the user, which is really interesting because, as I said, the only thing that people really pay attention to is the things that they are looking at. That goes both ways. If they don't look at something, they for surely have not seen it. And this is eye tracking has been used for ages and ages in doing user interface analysis, to do research on human behavior, and we're moving that possibility into VR, where attention data can be collected from the user. So, I just want to show you a small film. I hope the sound works. It's a small clip from our friends at Against Gravity, and you might recognize the game. And it's parlor trick. I love Rec Room, and this is an example of what you can do with actually representing the eye movements in this kind of avatar multiplayer experience. And the guys at Against Gravity, they're really experienced in eye tracking. They've been doing that for a long time, and they were an ideal partner for us to develop this experience. So it was a really quick thing for them to do. They started the work in December, and now we're here, and yeah, it looks good. So if you have the opportunity, if you're one of the lucky few that are able to go into the Valve ballroom during GDC, then you can actually see a demo of Rec Room. And for you as developers, I want to mention that there is work ongoing in order to create a standard API for VR. So it's managed by the Kronos organization, and the work has really kicked off in that. We're taking part in this work, and the aim is to have standard APIs for eye tracking in the first version of the specification, which only goes to show that this is a key part of the experience. I just want to mention that, of course, now we're starting to urge developers to start doing content for VR that is eye tracking enabled. And as Patrik said, we're extending our program where we work together with content developers to do eye tracking enabled games. We extend that into VR, and so that we are all as an industry are ready to actually have kick-ass content ready when the HMDs arrive that has eye tracking in them. And for that, we will also make all of these demos that I've shown, we make all the source code available. It's written in Unity, so that everyone knows how we did it and can be inspired by that. We will also work with select partners regarding making sure that there is hardware to test on as well, and Patrik will go into that as well in a while. So, yeah, that's me. We will have a QA in a while, but I'll just let Patrik wrap up here.
Okay, great. So thank you. If you are a developer and you're interested in working with eye tracking, the way you do is that you visit our developer zone. It's developer.tobii.com, and there you can sign up. And we're totally committed to our efforts in the PC gaming arena. That's really a lot of really exciting things are happening. So from a PC gaming perspective, I really urge you to sign up and take part of the SDK and start looking at this and see the opportunity that's created. Part of our model is that not only do we work with the game developers, but we also work we try to get the hardware vendors together with the games. So we do a lot of voucher solutions. So when they sell the hardware, we bundle with games and that kind of setup, just to bootstrap this market. If you're interested in VR, we will make available a dev kit during this year. It's not open right now. So I urge you to sign up, and we'll send you an email and tell you when that's going to be available. So I think that pretty much open up the floor for questions.
So the question was what's the status of learning eye skills using eye tracking in VR? And there's we get a lot of interest from companies that want to do HMDs using eye tracking, both for actually doing both diagnosing and also helping train some of the neurological diseases that can be shown and trained using eye tracking in the therapeutic ways. So that's for sure something that is going to happen, and the only thing I think is limiting that is the availability of of HMDs with eye tracking in them. But when they come, that will be for sure one of the things that is going to happen. And we've seen examples of people doing cognitive behavioral therapy using VR, and by adding eye tracking to that, you can actually make that even better. So if you look away from the spider, that it will move there you're looking. So so if you want to do that kind of, so you can actually really learn quite a lot from the behavior. And then on the technology maturity side, how accurate is it? Is it possible to do really microsaccadic things regarding microsaccades and so on? Well, at this point where the aim of the platform right now is to be at around 1 degree of accuracy and a half a degree of precision, which is sort of, and if that is sufficient for all the different uses that we are thinking of, especially in those very exact things, that remains to be seen. But as technology is evolving in our other business units where we do other kinds of eye trackers, we've been doing this since 2001, both for the research area and also for behavioral sciences area. We have exceptionally good eye trackers with very high precision and high frequency. In VR, eye tracking is an evolving technology, so we will get better and better. But the first step is to start exploring the first kind of therapeutical methods. Usually, it's if you look at the research-oriented high-performance eye trackers, they are usually have dedicated high-end hardware in them, and also have it's a function of how much light you send towards the eye and the nature of the cameras. What kind of frequency can you get? So the largest scientific eye trackers we have are like this big. But our consumer eye trackers, the 4C that we sell as a peripheral for gamers, it's very small. And it's the eye trackers we embed into a PC, it's even smaller. It's just a circuit board. And moving even further down in size, we are in what we do in VR. Actually have a small ASIC and cameras connected to it. Then we are really small. But then, of course, with smaller size comes less performance as well. So. But we have experience in the whole range of that. So,
but basically, we would not be able to do the things we're doing in gaming if it hadn't been for the fact that we're getting better performance at a lower cost.
Yeah.
So it's just, if you look at it from a 3-year perspective, the progression of quality of eye tracking has just improved. And it's not only about precision, but it's also about the percentage of the complete population that it works well with.
Yeah.
So it's a multidimensional kind of question, but it really has improved a lot over the last 3-4 years.
Yeah, it's quite easy to do an eye tracker that works for one person, but it's tremendously hard to make an eye tracker that works for 98% of the population, of different ethnic backgrounds, with eyeglasses or not, and so on. So, and that only comes with experience.
Text input in VR has been a really hard thing. Have you guys tried any text input methods using the eye tracking yet?
Writing text?
Yeah, it's like text input.
Like a glance keyboard of some kind?
Yeah, or like swipe in.
Yeah, swipe keyboard. So that's a very interesting use case, and just because of the lack of input methods you usually have in VR, that's an interesting avenue of research for us. On the PC side, just to mention, we do these kind of glance keyboards already, especially in our accessibility business, where we help people who are mute or paralyzed to use a PC or to actually communicate and to speak, because they can swipe with their eyes over a keyboard and form words that are read up to them. So the threshold to move this kind of experience into VR is really low. Okay. But at this point, we haven't explored it. We're focused on the gaming experience first. But that is one of the really cool use cases that we could do. And it's all about the size of objects that is optimal How large does the objects need to be in order for you to hit them sufficiently? But with swiping, you don't have to be that exact because you calculate the words. So that would probably work quite well.
Okay.
So thanks for the idea. No, I'm just kidding. No. So and it's totally natural for us because on the PC side, we worked on making eye tracking like a fifth modality compared to mouse, keyboard, touch, and voice. And the combination of modalities is usually the thing that makes it really working really well. And in VR, we have less modalities, so that means that eye tracking becomes very interesting very quickly, just for that case.
And just quickly, like, what's the performance savings using foveated rendering? Like, what % can you cut down the render?
Oh, that's how long is a string. It is very dependent on what kind of scene you're rendering and how. So graphics is a part you need to calculate the scene in the CPU, and there you don't get the savings. But on the GPU side, we've done quite a lot of experimentation. So we've seen everything from 30 to 70% less drawn pixels in a typical scene. And on the PC side, when we apply foveated rendering there, we can see that the frame rate, we can go up quite a lot in frame rate as well, which is always good for you gamers. So thank you.
I'm a user experience designer for games, and I've been using eye tracking to tell where people are looking for on the games and the user interface of it.
Cool.
And I'm curious, we're building VR games right now, and I'm curious as to where like UX design and testing, user testing for VR, if you guys are experimenting with like your eye tracking for VR with user testing, I guess, and like heat mapping. Yeah,
well, that's a very good question. So we have a long history in actually doing that kind of analysis on heat maps from user behaviors. And actually we have a whole business unit doing that kind of work. And they are working right now on doing that also in VR. Because there's a huge need for to create environments inside VR that you can use in order to study human behavior on it. And then on to your question, we do actually. So you saw a representation of gaze from a session. It's very easy to collect that data because the information, the amount of information contained in the eye tracking signal is that comes down to the host is very small. It's just gaze vectors and an eye position, and they're all time stamped. So it's very easy to connect the vectors to what you have just recently drawn in your scene. And that means that you can take the eye tracking signal and whatever you draw, whatever you do in the engine, and match the vector towards that. And using that, well, then it's all about doing the mathematical analysis on the numbers, basically, what you have. So I don't know if it was a good answer to your question.
No,
or
right. Yeah. I was just like trying to figure out the research side of it.
Yeah, well, there's a lot of things. So connect with me after the session, and I'll take your card, and I'll connect you with some of our research guys.
Cool. And I think if you're interested in that area, you should keep an eye open because our colleagues in Tobii Pro are working on this. So I think there's going to be some exciting stuff happening this year.
Cool. Thank you.
Hi. So I have access to the IX and I have access to Vive, and I've always wanted to bring them together. So it's cool to hear that you're doing that. I was wondering, are you working? Maybe you said this, I came in late, but are you making a separate device that goes along with the Vive, or is this going to be a sort of a revision to the Vive, or does it already work? What kind of hardware is this going to be?
So. On the PC, thanks for the question. So on the PC side, it's easy to do peripheral because of that you plug into a PC. In VR, however, due to the geometry of the system, the only way to get really good eye tracking that works on a large amount of the population is to integrate it, which means that on the Vive prototypes we have, it's actually everything is integrated. The only thing you see is the illuminators, and the rest of the eye tracking system is actually it's behind the lens, in between the lens and the display, because we don't want the user having to see the camera, and we also want to have pictures taken as much from the front as possible of the eyes. And that means that we actually hide all the technology inside. And that, of course, means that we can't develop a peripheral that is sold onto and that you buy and add to your Vive. So we need to work with all the manufacturers to integrate the product. And that's so the work we've done on the Vive is for exploring this technology. Of course, we would be super happy if someone like HTC would buy the technology and do a consumer version of it, but we have no news on that right now. But we are in dialogues with quite a lot of OEMs regarding this. But most probably the only successful, really good eye trackers you will see in the future will be integrated eye trackers for many different reasons, but mostly because of the fact that you get very steep angles if you put cameras on the edge of the lens, and then you won't take any good pictures, and then it won't track very well. And if you have eyeglasses, it won't work at all. So there you go. So it's going to be an integrated solution.
Okay, thanks.
Yeah, you're welcome. Good luck with your eye tracking projects. Thank you so much.
Thank you.